All right, so here we go with day 2 of review of exponents. So it's 4.5 more exponents because we're going to talk about some additional exponent rules that we need to know in order to be successful with what's coming up. So the first rule that we want to talk about today is the power rule. And power rule means power to a power. So we're taking an exponent to an exponent. And you can see in the little description it says keep the base the same, but multiply the exponents. So last time we were adding the exponents because we were doing the product rule, but now with the power rule, we're going to multiply the exponents. And I can show you in this first one why we multiply the exponents. So if we look at this first example, oh, my finger keeps doing that. That's annoying. All right. So y to the 8th to the 2nd power. Well, remember, an exponent tells us to multiply something by itself. So y to the 8th to the 2nd power means y to the 8th times y to the 8th. And if you remember from the product rule, we add the exponents. So we know this is y to the 16th. Well, if you just look, you can see that, hey, 8 times 2 is 16. So when we do the power rule, instead of adding the exponents, we're simply just going to multiply the two exponents that we can see. Okay, so 8 times 2 equals 16. All right, so if we look at the second example here, why does it keep doing that? We have 8 to the 4th to the 5th power. Well, if we multiply those two exponents, we know that 4 times 5 is 20, so this is going to be 8 to the 20th power. Okay, and then similarly here, and this one gets a little crazy because we have parentheses, we have brackets. Remember, parentheses and brackets are just containers, and whenever we have parentheses, multiple parentheses, we would generally prefer to use a parenthesis and a bracket just so we can easily differentiate between the two. So in this case, it's -5 to the 3rd power, but then we're taking that whole thing to the 7th power, so it just becomes -5 to the 21st power. Okay, so don't let the extra stuff there kind of confuse you. It's just there to kind of keep things a little better organized. All right, so let's keep going. So we can expand the power rule a little bit by looking at products inside of a power. So in this case, we have s and t, two different variables. We're taking it to the 4th power, and this is one where we might want to just remind ourselves that those have ones on them. And anytime we have multiple bases within a set of parentheses, so we have two bases, we have an s and a t, they're both bases. We need to apply the exponent that's on the outside of the parentheses to both of those bases. So this becomes s to the 1 times 4, or just 4, and t to the 1 times 4. So both of them just become to the 4th power. Okay, so anytime we have multiple bases within a parentheses, apply the exponent on the outside to everything that's on the inside, basically. Okay, so in this case, we have a variable and a coefficient. And when we have a variable and a coefficient, again, we can rewrite this. And that too actually has an exponent on it that a lot of people don't realize is there, but there is a 1 there. And there is a 1 there. And if we're taking it all to the 3rd power, it becomes 2 to the 3rd power, a to the 3rd power. And then in this case, we can simplify this one a little bit more, and we could say, hey, this becomes 8a to the 3rd power. Because generally speaking, if we have a number to a power, we're going to want to simplify that. We're actually going to want to do the multiplication that it's telling us to do. Okay, so let's look at another one. And this one ups the complexity quite a bit because we have a fraction, we have two variables, one exponent we can see, one exponent on the outside we can see. So if we just rewrite this whole thing with exponents, and remember there's ones on there, there's a 1 on the m, there's already a 3 on the n, so we can just leave that alone, and now we have a 2 on the outside. Now, all we have to do is multiply that 2 by every exponent that we see on the inside. So we end up with 1 squared over 3 squared. Now I'm going to interchange the language a little bit here, and you're probably going to notice that I just said squared instead of to the second power. You can say either one. We can say squared. We can 3 would be cubed, but then beyond that it becomes a little bit more complex. So that's why we just switch to the numbers and say to the second power, third power, fourth power, fifth power, and so on. So we have 1 squared over 3 squared, and then we have m squared. And this is where it's hard to come up with the term, but it's 3 times 2 is 6, so we just say n to the 6th power. Okay, and then we can simplify this a little bit because we have numbers with exponents. Well, 1 squared is just 1. 3 squared is 9. So we have 1 m squared n to the 6th. Okay, so there we go. Sometimes you might see this written a little differently, and it would be written like as a fraction. The whole thing is a fraction. We can just put the whole thing under 9, over 9. Okay, lots of rules. But once you start to figure it out, they all are interconnected, and it's kind of nice to be able to see that. You can see how they work. Okay, so m over n to the 7th. Pretty straightforward with this one because we know there are 1s on the m and the n, so we can immediately just say, hey, it's m to the 7th, n to the 7th. Okay, so we're getting a little bit more complex here. X to the 3rd over 3y to the 5th, all to the 4th power. So if we do this trick where we just rewrite things that don't have exponents, okay, so I like to do this because now I can see I have 3 things that I need to multiply by 4. I have a 3, a 1, and a 5. Okay, so I can write this as x to the 12th over 3 to the 4th, y to the 20th. Okay, and I did say that we should take anything that's a number to a power and simplify it. So we got to do a little simplifying here. And this is one where you might need to grab a calculator. We could go off to the side here and figure this out. So 3 to the 4th power is 3 times 3 times 3 times 3. And when in doubt, just multiply a pair of them and get 9. And we could actually multiply this pair and get 9. So 3 to the 4th power ends up being 9 times 9, which is just 81. So this is going to be 81y to the 20th on the bottom. All right, let's keep rolling. What do we got? Quotient rule and 0 exponent. All right. Quotient rule is harder than 0 exponent. 0 exponent is the nice way to finish here because it's pretty straightforward and simple. But it's easy to forget. But let's do the quotient rule first. So quotient rule. Quotient means division. So if we have a fraction and we have bases that are the same in the numerator and the denominator, we have to do some subtraction of the exponents. So we always want to do the subtraction wherever the exponent is larger. So the first example, the exponent is larger in the numerator, so I'm going to say x to the 5 minus 2 or x to the 3rd. Now I didn't write the 1 underneath, because it is a fraction, right? So notice how all the subtraction took place in the numerator. Okay. In the second example, you know what, actually let's do this. Let's just give you a reason for why this happens the way it is. So if we think back to the beginning when we took something like x to the 5th and we wrote it all out as 5x's, and then x squared and we wrote it as 2x's. Now the thing that we can do here is anytime we have x's in the numerator and the denominator, they can start to cancel each other out. So I'm going to cancel this one with this one and with this one, and you can see I'm left with 3 x's in the numerator. Okay, so that's why the subtraction takes place in the numerator, because basically if you look at what I crossed off in the numerator, it's 5 minus 2 of the x's in the top because there's 2 on the bottom. Okay, so it's 5 minus 2, it becomes 3. All right, now this one would probably be a good one to do the same way that we just did, instead of trying to say, oh, where do I do the subtraction? Until you get the hang of it, it's kind of a nice thing to just say, hey, let's just write it out. So we have s times t in the numerator, and then we have s times t times t times t in the denominator. And if we do the same thing where we do our canceling, we're going to cancel one s in the top, one in the bottom. So essentially what we did is we subtracted 1 from the exponent in the top, because we now have s to the 1 in the numerator, right? And then we're going to do the same thing with the t's, except we cancel 1 in the top and 1 in the bottom. Well, we subtracted 1 from the 3 on the bottom. I hope that makes sense. It can be a little tricky to get your head around it sometimes, but it ends up becoming s over t squared. Okay, and essentially this s is because s to the 2 minus 1, and the t is down here because it's t to the 3 minus 1. All right, hopefully that made sense. Oh wait, we got another one. All right, so now here we have a case where the exponents are all bigger in the numerator. So all the subtraction is going to take place in the numerator, and there's a 1 here and a 1 here. So this becomes 2 to the x, so now, sorry, 2 times x to the 5 minus 1, or 4, and y to the 2 minus 1, or 1. And generally speaking, we wouldn't write that 1 on the y in our answer, but if you do, that's all right. Either one of these two are perfectly fine answers for this problem. Okay, last thing, zero exponent. Like I said, the zero exponent is easy, because, well, there's one little trick that you have to be careful of, and you'll see that in a second. Anything to the 0 power is 1. All right, so absolutely anything to the 0 power is 1. So in this case, 3 to the 0, 1. 3 100ths, parentheses, 0 power, 1. Okay, if you want, we can apply a rule here. We can say this is 3 to the 0 over 100 to the 0. Well, it just becomes 1 over 1, which is just 1, right? Okay, so you can see how there's an interconnection between the rules there. And now this is where it gets tricky, because if I ask the question right now to raise your hand if you think the 0 applies to the x or both the 4 and the x, a lot of you would say both the 4 and the x. But from last time, I think was it last time? Yeah, it was last video, I mentioned that parentheses, super important. If it looked like this, then the 0 applies to the 4 and the x. But we don't have parentheses, so we don't have that. So in this case, the 0 only applies to the x. So this becomes 4 times 1, because it's x to the 0 power is 1. So our answer is 4. All right, again, down here is your assignment. I explained a little bit about this last time. There's no odds and evens in this one, but for those of you who only do the beginning and the end, you need to do everything in between here. So you have to do 55 through 60. So 55, 56, 57, 58, 59, 60, and then same thing for the other two ranges, all right? And you'll see the page numbers here. That's because if we were in school, we would be looking at a book that has pages in it, and you'd be able to go look it up and see what the problems were. All right, if you have any questions, let me know.